Hello, my dear children. So, as I said you in the last class, we will be doing numericals based on levers today. So, I have taken the numericals from your book, okay, from the first unit of the chapter based on numerical levers, okay. So, I hope you have already made aware of yourself to the formulas that we have here, isn't it? We have the mechanical advantage load by effort equals to load by effort, isn't it? Velocity ratio is equals to velocity of effort to the velocity of load. Then we have efficiency, the formula for efficiency. Then you have the principle of levers, that is load into load arm equals to effort into effort arm, isn't it? So those are the formulas that we are going to use here. All right. Okay, so now let's come to the first numerical, number 1. Let's read the question. The question says a crowbar of length 120 centimeter has its fulcrum situated at a distance of 20 centimeter from the load. Calculate the mechanical advantage of the crowbar. So first of all, let us jot down the things which are given. Okay, so given, you see the total length of the crowbar is given. Crowbar like we in Nepali we call it as grai khode kaati nikalne huncha ni, that is what we call crowbar. Okay, so total length of crowbar equals to 120 centimeter. This is given in the question, isn't it? And the fulcrum means this is the point through which the lever rotates, isn't it? That is called the fulcrum. And the fulcrum bada load sama bhako distance la we call it as load arm, isn't it? So the distance is 20 centimeter from the load. So fulcrum it is 20 centimeter away from the load. So that means load arm is given, isn't it? So load arm is 20 centimeter. So 120 bada, if you remove 20, the remaining part is the effort arm, isn't it? So you can easily understand here, isn't it? So effort arm equals to 120, that is the total length of the crowbar, minus load arm will give you the effort arm. So 100 centimeter is the effort arm. So and what is the demand of the question? The question is telling you to find mechanical advantage. So we know mechanical advantage equals to effort arm divided by load arm, that is 100 divided by 20, 0 and 0 gets cancelled, 10 by 2 means 5. So here you write this statement, therefore the mechanical advantage of the crowbar is 5, just 5. Since you all know that mechanical advantage has no unit because it is the comparison of same physical quantity. So here effort arm, load arm, both of them are measured in centimeters, isn't it? So centimeters and centimeter gets cancelled, so leaving behind no unit. So mechanical advantage has no units. All right. Okay, so that was your number 1. You can again rewind it and rewatch it if you are getting confused. Excuse me. Okay, now let's move to the next question. The next question that we are going to discuss today is question number 3. Okay. Okay, so let me read the question now. Force of 5 kgf, okay, is required to cut a metal sheet, okay, a shear. So here, okay, so I have a spelling error here. Okay, this is not SHERS, it should be SHEARS. Okay, used for cutting metal sheets. So to tin काट्ने हुन्छ नि कैंची जस्तै, it's not actually scissors. Okay, this metal cutters have long handle, blades are shorter and handles are made longer. Why? To increase the mechanical advantage or to decrease the mechanical advantage. So find it out. Okay, so here we need to multiply the force. So I am giving you the hint here. Yes, so large amount of force is required to cut the metal because metals are a little bit tougher to cut as compared to clothes and papers, isn't it? So that is why it has longer handles. So here let's come back to the question again. The force of 5 kgf is required to cut a metal sheet. Shear is used for cutting the metals has its blades 5 centimeter, while its handle has the length of 10 centimeter. What is the effort needed to cut the metal sheet? So here we have been asked to find the effort, isn't it? So if I have to draw the figure, okay, it will look somewhat like this. This is the handle, okay, this is the handle, and this is the blade. So this is the point through which our lever rotates. So this is my fulcrum. Here we'll have load, okay, and the load arm here is 5 centimeter, and this distance, the effort arm, is 10 centimeter. So if I have to draw the figure, it looks like this. Okay, so let us write the given thing. Given effort arm is 10 centimeter, load arm is 5 centimeter. We are asked to find effort, isn't it? Yes, and to find the effort, you know the formula, MA equals to L by E, isn't it? Load by effort. Yes, but here you know the load, okay, is given, and that is how much? 5. The load given here is 5, isn't it? The force of 5 kgf is required to cut the metal sheet. This is one, isn't it? Yes. So first of all, we need to find the mechanical advantage. So here you know mechanical advantage. So let's write here. We know mechanical advantage equals to effort arm by load arm. Alright. So effort arm is 10 centimeter. Load arm is 5 centimeter. Centimeter gets cancelled. So 5 ones are 5, 5 twos are 10. So the mechanical advantage here is 2. Alright. Now we need to find the load. Okay. So again, mechanical advantage is load by effort, another relation, isn't it? So effort, now if I make the effort as the subject, I'll get load by mechanical advantage. So that gives me the value of load is 5 as per the question, divided by mechanical advantage is 2. So 5 by 2 is 2.5 kgf. That will be the unit. So write the statement here. So this is question number 3. So if you are getting confused here, we are using the same quantity, physical quantity, that is mechanical advantage and mechanical advantage, but you have to be clear here that the first mechanical advantage that we have used, the relation for mechanical advantage, is with respect to effort arm and load arm. But here in the second one, we have used the relation for mechanical advantage with reference to load and effort. So please do not get confused here. All right. Okay. So now let's move to the next question. The next question that we are doing here is question number 4. All right. Here the question number 4 says the diagram below, okay, shows a lever which is in used. So here you can see a lever. So you have a long lever. Okay. AB is the lever, and here you have the fulcrum, okay, and here you have the load which is of 15 kgf, and here you are applying the effort. So the question is, number A, to which class of lever does it belong? Number B, if AB equals to 1 meter, so AB, the entire length of the lever is 1 meter, and AF, this one, AF is the is equals to 0.4 meter. Find the mechanical advantage. And lastly, number C is calculate the value of effort. That is what the question tells us, right? Okay, the first one is, to which class of lever does it belong? Now here you can see that this side is my load, and here I have effort, and in between load and effort I have the fulcrum, the point through which the lever rotates. So fulcrum is lying between the load and effort. So such kind of lever, okay, is called class 1 lever. So number A, lever, okay, this lever belongs to class 1. Okay. Number B, AB, the entire length is given, isn't it? Yes, that is how much? 1 meter. And the second one is AF. Now what is AF? A is the point in which at which the load is suspended. So load taken fulcrum is your load arm, isn't it? So load arm is how much? 0.4 meter. So what will be the value of FB? So FB will be AB minus AF, that is 1 minus 0.4 meter, that will give you 0.6 meter. So that is my what? Effort arm. So effort arm is 0.6 meter. All right, so I'm been asked to find mechanical advantage. So mechanical advantage equals to effort arm by load arm, isn't it? Effort arm by load arm. So or mechanical advantage is equals to effort arm is 0.6 meter divided by load arm is 0.4 meter. So meter in meter gets cancelled, decimal also gets removed. So I'll have 6 by 4. 6 by 4 means 2 3s are 6, 2 2s are 4, and 3 by 2 means 1.5, and no unit since it is mechanical advantage. All right, so number B, I got the solution. So write the statement here. The mechanical advantage is, or its mechanical advantage is 1.5. Okay. Number C, what is the load given here? So given here load is 15 kgf. If you see the question, isn't it? Yes. So what will be the effort? Effort has been asked to find, isn't it? So effort is equals to, we are using the same relation, that is MA is equals to L by E, load by effort, isn't it? So I'll have load by MA here. How much is the load? Load is 15. What is the mechanical advantage? 1.5. So that will give me 15 into 10 by 15 after I remove the decimal. So 15 and 15 from the numerator, and the denominator gets cancelled by 1 each, leaving behind 10. So I'll have 10 kgf. So don't forget to write the statement now. So we got the solution for number C also. So the value of E equals to 10 kgf. All right. Okay, so now you can pause the video, copy the solution. Okay, if you don't understand, you can watch the solution again, okay, before you jump to question number 7. So the next question now we are doing is question number 7. Now what do question number 7 say? It says 4 meter long rod. So here the first information given is the rod whose length is 4 meter of negligible weight is supported at a point of 125 centimeter from its one end, and a load of 18 kgf is suspended at a point of 60 centimeter from the support on the shorter arm. Okay, then what do you have to find? Find, okay, number 1, if the weight W is placed at a distance of 250 centimeter from the support on the longer arm, find W. Number B, if a weight of 5 kgf is kept to balance the rod, find its position. And number C, to which class does it belong? So this is our question. Okay, so if I have to draw the picture, it looks like this. I have a long rod which has a length of 4 meter. Okay, this has 4 meter. 4 meter means 400 centimeter. Okay, negligible weight is supported at a point of 125 centimeters. So suppose say this is 125 centimeters. So here I have the fulcrum, okay, from its one end, and a load of 18 kgf is suspended at a point 60 centimeter from the support on the shorter arm. So this is my shorter arm. यतापट्टि छोटो छ, यतापट्टि लामो छ. So लामो भएकोमा चाहिँ के झुन्डाको रहेछ? Load of 18 kgf. Are you getting my point? So to balance this, I have to suspend something here on the others or the longer side. Yes. So here my fulcrum is in lying between the load and the effort. So this kind of lever belongs to class 1 lever. So I got the answer for the last question, that is question number C, isn't it? Yes. Okay, now let's go to the question. Given Okay, total length of rod equals to 4 meter, and you know 1 meter equals to 100 centimeter, so 4 meter will be 400 centimeter. Okay, number A, we are doing number A now. Now 18 kgf load is placed, okay, at 60 centimeter from the support. Okay, W kgf weight is placed. See, I'm writing this from the question. Okay, W, see here you can say W kgf weight is placed, okay, at what distance? At 250 centimeter from the support. Okay, now let, okay, you understood, no? Okay, so not late here. So now what happens is that we have placed the W kgf weight, okay, at 250 centimeter from the support. Now you know the principle of moments that we have drawn, isn't it? Or you can apply the principle of lever also here. So as per the principle of moments, okay, load into load arm, okay, equals to effort into effort arm. Okay, if you get confused when you are writing directly, you can write here load into load arm equals to effort into effort arm. Okay, so here what do I get? I get W equals to 18 into 60 divided by 250. So 0 gets cancelled here. 6 8s are 48, 6 1s are 6 plus 4 is 108 divided by 25. So when you divide that, you will get 4.32 kgf. So that is the W. Alright, clear? Now question number B. What does question number B says? Question number B says, if the weight of 5 kg is kept to balance the rod, find its position. So now for question number B, the weight given is W equals to 5 kg F. What is it? 5 kg F. Now what are we asked to find? We are asked to find the distance, that is effort arm. Okay, so by the principle of levers, load into load arm equals to effort into effort arm, isn't it? So load is 18, effort load arm is 60 centimeter. Here the effort is given as 5, okay, into the effort arm we do not know, that is I will write as D. All right, or I'll get D as the subject here, so I'll get 18 into 60 divided by 5, 5 ones are 5, 5 twelve are 60, 18 into 12 will give me 216 centimeters. So I must keep, okay, I must keep the load of weight of 5 kgf at a distance of 216 centimeter on the longer arm. So write that statement here. All right, okay, now question number C. To which class, okay, of lever does it belong? So now it's initially only I told you that here the fulcrum is lying between the two between the load and the effort, so it belongs to class 1 lever. All right, so this was your question number 7. All right, so now we'll be doing 2 more sums Okay, so in between you can pause the video and copy and rewatch it if you are getting confused somewhere. And even after rewatching it, if you are confused, you can text me. Okay, you can ask me in the class group. All right. Okay, now we go to question number 10. So figure below shows, okay, a wheelbarrow of mass 15 kilogram carrying a load of 30 kgf with the center of gravity at A. So this is the center of gravity. Okay, it means this is the point at which, okay, it gets balanced. The point B and C are the center of the wheel here, and tip of the handle. So B is the center of the wheel, C is the tip of the handle. Okay, such that the horizontal distance from A to B is 20 centimeter and A to C is 40 centimeter. Find number A the load arm, number B the effort arm, the mechanical advantage, and number D the minimum effort required to keep the leg just off the ground. So number A. So here you can see this is the point through which this entire lever is rotating or turning about. So this is your fulcrum. Okay, so this is the place where you place the load. So here you have the load, and here you place your hand to lift it. So here you apply the effort. So load is lying between the fulcrum and effort. So this lever belongs to class 2 lever. All right, so fulcrum taking load someone is called the load arm, isn't it? So number A, load arm will be how much? B A, that is 20 centimeter. Number B is effort arm. Effort arm is here, A to E, okay, and that is, sorry, A to C, okay, and that is how much? 40 centimeter. Am I correct here? Am I correct here? No. See, effort arm is the distance from the fulcrum to the effort. Okay, यो छ fulcrum यहाँ छ, effort यहाँ छ, यो handle मा छ effort. So this distance, and that total distance is 20 plus 40, isn't it? That is 20 plus 40. So effort arm is actually how much? B देखिनको C सम्म, that is 20 plus 40, that is 60 centimeter. All right, and number C, what do you have to find? Mechanical advantage, and you know mechanical advantage is, okay, is given by effort arm to the load arm, that is 60 divided by 20, 0 0 2 3 are 6. I get mechanical advantage as C. Is that okay? Is that understood? Okay. Now number D is the minimum effort required. So let's see the total load. How much is the total load here? The total load, okay, here is 30 plus how much? 15. So here you see 15 and here you see 30. So the total load is here 15 plus 30, that is 45 kgf. So what will be the effort? Effort will be load divided by mechanical advantage. Load is now, total load is 45, mechanical advantage we have found out is 3. So 3 1s are 3, 3 1s are 3, 3 5s are 15. So you'll get 15 kgf. All right. So here we got the solution for all the 4 questions. Okay. A was load arm, B was effort arm, mechanical advantage, and the effort that is required. Okay. So now let's move to the next question. This will be the last question for today. Question number 12. Okay. Question number 12 says a fire tongue, okay, chimta, okay, has its arm 20 centimeter long. It is used to lift a coal of weight of 1.5 kgf by applying an effort at a distance of 15 centimeter from the fulcrum. Find the mechanical advantage and the effort needed. So let's jot down the given thing. Given, okay, the length of fire tongue, or you can say the arms of fire tongue. So fire tongues, okay, has its arms equals to 20 centimeter. You're applying the effort at what distance? 15 centimeter from the fulcrum, so that would be your effort arm. So effort arm is 15 centimeter. So the remaining portion, okay, that is 5. So 5 plus 15 will give you the load arm. That is the total length of the arm of the fire tongue. So that will be your load arm. Okay, so number A, what you have to find? Mechanical advantage. So mechanical advantage, you know the formula, effort arm by load arm. Effort arm is 15 divided by 20. So 5 3s are 15, 5 4s are 20, 3 by 5 means 0.75. So the mechanical advantage of the fire tongue is, you write this statement here, 0.75. all right. And number B, what do you have to find? You have to find the effort. Now you know the formula to find effort, isn't it? Effort equals to load by mechanical advantage, right? And the load of the weight of the coal is given, that is how much? 1.5. so that will give you 1.5 divided by 0.75. that makes or gives you 15 into 100 divided by 75 into 10 when I remove the decimal. So this and this gets cancelled. So 5 3s are 15, 5 1s are 5, 5 4s are 25, 5 1s are 5, 5 3 1s are 3, 3 5s are 15, and 5 2s are 10. So I get 2 kgf. So the effort required here is 2 kgf. Okay, and write the statement at the end. So I hope you have understood all these sums that we have done today. You can re-watch it again if you are getting confused, okay, and even after rewatching the videos, okay, rewatching the solution, if you're not able to get it, you can always text me, okay, and you can ask me in the class group. Okay, so please ask in the class group so that everyone gets benefited. All right, so that's all for today. Please copy all this solution in your copies, okay, and you will show me this in the evening. All right, by 5 all solutions should reach me, so that I will know that you are following my lessons. All right, so that's all for today. Have a good day.